Yes, good morning, students. So we have stopped at the links. Now we are going to continue with the topic. So as you know that different types of the links are going to be available. So that is the coaxial cable, optical fiber, a twisted pair. Is it clear? Even in the space also, we people are able to transfer the radio waves, microwaves, and the infrared beams. Now we are going to see about the physical media. It is used to propagate the signals. Why you are going to use the physical media? The physical medias are help us to propagate the signals. These signals are actually electromagnetic waves traveling at the speed of light. One important property of an electromagnetic wave is the frequency that is measured in a hertz. Now you are going to see about another one, that is a wavelength. The distance between a pair of adjacent maxima or a minima of a wave, typically measured in meters, is called the wavelength. And electromagnetic waves travel at the speed of light. That speed divided by the wave's frequency is equal to its wavelength. Okay, so one example is there about an voice grade telephone system, which you can refer it. You are going to get the idea. The next one here we are going to see about that electromagnetic waves span a much wider range of different frequencies are there, as you are going to see it here, that is a 10 raised to 0 to 4 up to 10 raised to 24. So this electromagnetic spectrum shows which media are commonly used to carry which frequency bands. Is it clear? So now here you are going to be say that the radio, so radio waves, the frequency band, maybe here they have been shown of 10 raised to 4 to 10 raised to 8, from 10 raised to 8 to 10 raised to 10 and above is a microwaves will be there, and next one is the infrared will be there, ultraviolet rays is there from 10 raised to 14 16, and x-rays is there, gamma rays. These are at a very high frequency bands. Now the below is another one example, that a satellite. So the frequency band which is used by the satellite, here they have given the range. Fiber opticals will be there, so that is 10 raised to 14 and 10 raised to 15 will be there. Coaxial cable 10 raised to 5 up to more than 10 raised to 8, that is a frequency band. Okay, AM is there, amplitude modulation. FM is there, frequency modulation. Okay, so this is a radio signals. And next one is the TV signals are there, that is the TV about 10 raised to 7 and about 10 raised to 8 terrestrial microwave. So these are all the different types of the carrier frequency bands. Okay, so physical media carrying signals in the form of electromagnetic waves. Such links provide the foundation for transmitting all sorts of information. Okay, now you are going to see the next one, that is another attribute of a link, is that how many bit streams can be encoded on it at a given time. Is it clear? So now here it is that if only one bit stream, means that it supports the data is going to be flowing in only one direction at a time. Such a link we call it as a half duplex. If two bit streams can be simultaneously transmitted over the link at the same time, one going in each direction, that is in the opposite direction, such a link is said to be a full duplex. Another property of a link that we are interested in at this stage is a very programmatic one, that is the answer depends on how far the link needs to reach, how much many of have to spend. Is it clear? So here it is that, so different types of the um, cables which are going to be available, that is the common types of the cables and fibers available for the local the links and all. So what bandwidth they are going to be support and what distance they are going to be support. So you are having a category 5 twisted pair, so bandwidth it is going to be support up to 10 to 100 mbps. You can use it distance up to 100 meter. Okay, thin net coaxial cable, it is also supporting 10 to 100 mbps, supports a distance of up to 200 meters. Thick net coaxial cable, it is also support up to 10 to 100 mbps, and the distance we can use up to 500 meter. So that is a thin coaxial cable and the thick coaxial cable. Each segment, the length of that segment is up to 200 meters, and next one is a 500 meters. If you are going to use the fibers, that is a multi-mode fiber, it can support up to 100 Mbps, and distance you can use up to 2 kilometer. Single mode fibers will be there, so very high bandwidth, 0.1 to 10 Gbps will be there. The distance it can use up to 40 kilometers. So the next one here, we are going to see about the leased lines. Next one we are going to see about leased lines. Okay, so if the two nodes you want to connect or on opposite sides of the country, or even across the town, then it is not practically to install the link of yourself. Is it clear? So the only option was to lease a dedicated link from the telephone company. You cannot own your individual the network. Is it clear? So that's why what you have to do, the only option was to lease a dedicated links from the telephone company, through which you people are able to communicate from one part of the country to the another, or one computer to the another, across the country, or either it may be the across the continent. Is it clear? So now what are the common bandwidths are going to be available for the carriers? So different bandwidths available here, so from the telephone company. So here the services are there, so different carrier services. One is the DS1, okay, DS3. So this DS1 and DS3 are also called T1 and T3 respectively, or relatively the old technologies that was originally defined for a copper based transmission media, that is a digital subscriber lines. So DS1 is equal to the aggregation of 24 digital voice circuits. Is it clear? One DS1 line is an aggregation of 24 digital voice circuits. Each circuit is of 64 kbps. Is it clear? Now the DS3 line is equal to 28 DS1 links. Now we are going to see about STS1, STS3 and so on. What do you mean by this STS? Synchronous transport signal. So all the STSN links are for optical fibers. So these STSN links, so we are going to use it for the optical fibers to transfer the signal. So now STS1 is the base link speed, and each STSN has a n times the bandwidth of the base, that is a STS1. Say for example here you are having a STS1 is of 51.840 Mbps will be there. Now but STS3 is 3 times, STS3 is 3 times of STS1, so that is 155.52 Mbps. So that's why they are going to say that STSN has n times the bandwidth of STS1, that is a baseline. Okay, so this is about the leased lines. The next one is about a last mile links. So in the last mile links you are having the different types are there. One is the POTS, ISDN, DSL and the CATV. Okay, so now POTS. So what is the available, the bandwidth here? 28.8 up to the 56 kbps will be there. In the ISDN you are going to get 64 up to 128 kbps will be there, and then the DSL line you are having 128 kbps up to 100 mbps, and in the CAT TV from 1 to 40 mbps. So these are the common services available to connect your home. Okay, so now here is going to say that why you have to go for the last mile links, why should not we go for the leased lines. Okay, so now we are going to say that if you want to connect your individual computer to the network, so if it is present in your home, Okay, so you can't afford a dedicated lease lines. They range in a price from several $100 a month. Okay, for a DS1 link across the United States. Okay, so therefore we can't afford it. Then there are less expensive options are going to be available where the common man can afford it, so through which he can connect to the internet. We call these last mile links services. Is it clear? So typically these last mile links services are used to connect a home to an existing network. Okay, so first one here we are going to see about the ports. Is it clear? Ports, we have to use a conventional modem over a POTS. What do you mean by POTS? This is one of the oldest telephone service. That is a plain old telephone service, or we call it as a PSTN. Is it clear? This is the another that is one the oldest telephone service is there. So public switched telephone network, we call it as a public switched telephone network. This is one of the oldest one network that we call it as a POTS, plain old telephone services. Today it is possible to buy a modem that transmits the data at the 56 kbps over a standard voice grade lines, and for less than $100 it is affordable. So through the modem, so if you are having a telephone connection in home, you people are able to purchase just the modem. Through that you people are able to connect to the internet. The next one here you are having an ISDN, DSL, and next one is a CAT TV. Is it clear? So before going to the next one, we are going to see about one theorem called as the Shannons Theorem. Okay, so what is the use of this particular theorem? Why you have to use this theorem? So the Shannon theorem can be used to determine the data rate at which a modem can be expected to transmit a binary data over a voice graded telephone lines. As it clear, so you are transmitting the binary data over a voice graded telephone lines. Now you have to determine the data rate at which the modem can be accepted to transmit. Is it clear? So that's why here he has been defined one particular the formula C is equal to B log 2 in the bracket 1 plus S divided by N. What do you mean by the C? C is the achievable channel capacity which is measured in the hertz. B, what is the B? B is the bandwidth of the line. What is S? S is the average signal power. What is N? N is the average noise power. What is S divided by N? Signal to noise ratio is usually expressed in the decibels. Okay, so to calculate a dB, so dB is equal to 10 into log 10 and in the bracket S divided by N. Is it clear? So this is the formula of that Shannon's theorem which is used to calculate the data rate at which a modem can be accepted to transmit. Okay, so we'll stop it here. So next one here we are going to see about a ISDN services.